Hello, strategist, and welcome to Applying Scientific Methods to Business Problems and Opportunities, with a special emphasis on our course subject, strategy. I'm Rick Hubbard. This is for BATM 495 and anyone else that would value seeing this video. Glad you're here. As the great detective says, you see, but you do not observe. The distinction is clear. That would be Sherlock Holmes in A Scandal in Bohemia. Also in the same work by Sir Arthur Conan Doyle, it is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. Sherlock Holmes in The Adventure of the Copper Breeches said, "Data, data, data," he cried impatiently. "I can't make bricks without clay." So are these insights from the character described as the greatest detective in literature useful to us in business, in strategy, in decision making? Well, that's for you to judge. This course advocates for your benefit throughout your career epistemic rationality. Epistemic rationality is the combination of art and science of systematically achieving the most accurate beliefs, understandings, insights, etc., possible about reality. All of the topics, the readings, the assignments, the tools used in this course are intended to equip you with the ability to successfully apply epistemic rationality throughout the course of your career. One way to achieve epistemic rationality is the use of the scientific methods in a business context. Let me reaffirm, these approaches are very applicable to business. While there isn't a single uniformly accepted definition of the scientific method or methods, the following definition is useful for our class's purposes. You will probably discover other definitions during your explorations. The scientific method is a way of conducting empirical research following rules that specify objectivity, logic, and communication among a community of knowledge seekers and the connection between research and theory. This is drawn from a book called How It's Done, An Invitation to Social Research by Adler and Clark. The key words in this definition include empirical, objectivity, logic, communication, connecting research, and theory. Let's delve a little deeper. Using scientific methods in business promotes critical thinking, decision-making, well-formed strategies, objectivism, observations, independence, evidence, the use of data, reasoning with logic, skepticism. If you recall, we've discussed the need for professional skepticism in business, analysis, substantiated conclusions, just to name a few of the beneficial aspects of using these approaches. Here's some examples of possible uses of scientific method in business settings. After graduation, imagine you're involved in a key strategy discussion addressing the question, should we expand into the new, whatever that might mean, market? It could be a new geography. It could be a new set of customers. It could be a new set of technologies. We'll just call it the new market. Well, could you use data to help with that, collecting and analyzing data? Would reasoning help? How about sales are falling? We need a new marketing campaign now. Well, that is a mental model of a way to address sales are falling, but is a new marketing campaign the only thing to do? Is it justified given the specific setting and context of whatever inquiry this happened to be? Could data analysis, reasoning, empiricism, rationalism help address that question? What new features should we add to our product or service? How about, will this marketing campaign successfully increase sales to meet our annual revenue forecast or not? The new marketing campaign is a dismal failure. We spent a year developing and messaging our new position in the marketplace, but here we are 6 weeks after the marketing launch. Sales are declining at a horrifyingly rapid rate. Is there any sane reason why we shouldn't kill the new campaign right now and revert to our old tried and true positioning and messaging? What do you think? Would data and reasoning help address that question? How about which training programs will have the greatest positive effect on our productivity? Before we submit our contract to the client, let's confirm. How do we know the project's envisioned approach, schedule, and budget will result in the desired outcomes, customer satisfaction, and margin contribution for our organization? Would data and reasoning help there? The sales team has anecdotal evidence that a small yet rapidly growing number of customers are unexpectedly using our product as a solution for problem. Product wasn't designed for that purpose. Engineering has safety concern. Legal wants to issue a warning bulletin advising customers not to use product for problem purposes. On the other hand, product management and marketing see this as a fabulous opportunity and want to make significant investments to upgrade product as a solution to problem and capture a new market. What should we do? Would you agree that these example business problems are strategic in nature as problems or opportunities? Is there a long-term enduring effect? Is it difficult or impossible to reverse a decision, to do or not do, or approach or not approach, or take one path over another path to any of those questions? So what would you do faced with questions like this? Well, let's try and see what happens. Maybe we should take a gamble. I have an opinion about that. Let's act on my opinion. No data, no analysis, but I think we should do it. I think we shouldn't do it. Or maybe it would be beneficial to obtain and use data, apply analysis, do reasoning, etc., and form a justifiable conclusion. And a specialization of bullet number 4 is what I call TBI. Test before invest. We don't know if this new marketing campaign is going to work or not. Maybe we should run a test and see what happens. That would be collecting data, analyzing it, reasoning, etc. I just want to stress that the scientific method, the term, is actually much broader than science. It is absolutely applicable in business too. For example, many consulting firms, I'd say the majority of them, use some version of the scientific method, frequently a proprietary methodology that they have developed, maybe to address a specific problem, so they may have multiple methodologies, but it's the basis of many consulting engagements as well. So it's not necessarily the term scientific method that's important, but it's a method of approaching solving a problem or fulfilling or pursuing an opportunity that's really important. So don't get impeded or don't block your thinking by the use of the word science. It's also applicable to business. Let's understand for just a moment and clarify the realm of science and scientific methods, and you might see how these apply to business as well. So we start off with, in the realm of science, we have the twin pillars of rationalism and empiricism. Rationalism includes logic and reasoning, forming rational arguments. Maybe you've had that in some of your prior classes. Empiricism includes observations and experiments. Now, there is one other thing that sometimes crops up in the research literature, what are sometimes called non-empirical research. Illustrations that might include historical interpretation of events. Well, I think that event in history meant this. No, I think it meant that other thing. Well, it's pretty hard to observe it because it's in history and you can't run an experiment. Well, another example is a philosophical examination of ideas. Is man truly free? That's a classic philosophical question. We don't know how to observe that with particular fidelity, and we don't know how to run meaningful experiments on that question. So we're going to ignore those for the purposes of our business class. So in our business class, we are going to focus on the empiricism and rationalism aspect of science, understanding that we are applying in a business context what is frequently called methodological naturalism. That big term, methodological naturalism, means natural or material effects must have natural or material causes. So there has to be a cause and effect relationship. We may not understand that relationship. it may be difficult to pin down, a natural or material effect has a natural or material cause. So that's interesting because there's another realm of thought dealing with unsubstantiated beliefs, unsubstantiated opinions, magic, the realm of the supernatural, the spiritual realms, all those other things, where these ideas in science don't apply. Fortunately, there is a very clear demarcation between the two, and that deals with evidence. Specifically, in the realm of empiricism and rationalism, evidence should be able to be tested and have the characteristic of being falsifiable. Let me be very clear. That doesn't mean that the evidence is necessarily falsified. That means it has to have the ability to, when appropriate, be falsified. My conjecture is X. I collect data. I run an experiment maybe or form some observations, and the collected data refute my conjecture. That would be an example of falsification. Maybe the data confirm my conjecture. So we need to have some ability to clearly demarcate between confirmation and refutation. This is not to say that science is right and the realm of the beliefs, supernatural, spiritual is wrong. That is not the point at all. That does mean that there's a demarcation between using evidence, testable and falsifiable evidence, and not. That means that whatever methods work in science are not well suited for the realm of the supernatural. Whatever methods work in the realm of the spiritual, supernatural, magic, etc., are not well suited for science. And methods in either realm, what is sometimes called non-overlapping magisteria, or NOMA, N-O-M-A, whatever works in one realm of the non-overlapping magisteria is not suitably applied in the other realm. Except for cats. Cats, of course, can do whatever they want because they are vastly mysterious quantum creatures. Just kidding. There is a couple of realms of thought that span science and the realm of belief and supernatural, etc. And that's skepticism. In this course, we advocate skepticism. Show me the data. Let's step through the reasoning. Let me see how that conclusion is supported. That's being properly skeptical. There is a fuzzy demarcation, though, between the realm of skepticism and the realm of denialism. Denialism uses many of the same methods or approaches that you might expect in skepticism. There's sort of a perverse sense. There is, however, a frequently observed characteristic of denialism that makes it different from skepticism or science. And that is, denialism frequently, but not always, starts with a desired conclusion, then selects only the data and the reasoning that supports that conclusion and kind of ignores everything else. In the realm of science and skepticism, we tend to start with data, go through reasoning, end up with conclusions that are based upon the empiricism and rationalism of data and reasoning, and we end up with the conclusion. So the major distinction here is, what is the starting point? Those people and arguments that start with a conclusion and select only the data and reasoning to support it might be involved with denialism. Sometimes that's called cherry picking, by the way. So what does this mean to you in a business context? As you're engaging with people in your career, you're going to hear beliefs, claims of magic, sort of. You're going to encounter denialism. You're going to encounter skepticism. You're going to encounter science. You're going to encounter empiricism, rationalism. You're going to encounter impatience, sometimes all from the same human being. It can be quite noisy and chaotic and difficult to discern what's going on. But it's beneficial for you to understand the realm of empiricism and rationalism that we frequently call the scientific method. Understanding that the fundamental underpinning is natural or material effects must have natural or material causes. Let's just reaffirm something. There are many scientific methods. Although in junior high school it was presented as the method, that's actually not the case. There are many models, many techniques, many aspects that you might use, but they all follow kind of a general set of stages of how to conduct a scientific inquiry, or in our case, we might call it business research in our specific case. So here is a baseline scientific method. It's very important that you understand you should examine this baseline scientific method and adapt it for every application that you might encounter. You might spend more time in data collection on one project or engagement, less time on the next one. You might spend more time in analysis. You might spend more time focusing on the logic you're applying to reason through your conclusions. In one case, less time in another. Keep in mind the limits of bounded rationality. Knowledge, time available, and our ability to process information. Those are going to affect what you might or might not do in any one situation. So you want to be mindful that you're going to adapt this. And I just suggest reading the Wikipedia article. It's a great source. Specifically, about a third of the way from the top in the article, there's a section called Elements of the Scientific Method. And it calls out what the article refers to as 4 important elements of characterization, hypothesis, prediction, and experiments. And probably a little bit more to the story, but it's a good starting point. Specifically, you'll want to pay attention to the 8 steps recorded in that article, at least as this is being recorded, which is at the end of August 2014, almost the beginning of September 2014. This is being recorded. That Wikipedia article has 8 steps, which are pretty good. Keep in mind, it's not the way, it is a way, and you are expected in this course to apply appropriate professional judgment in making any adaptations necessary, for example, for your term case project. Here is a representative model that I trolled around on the internet and I found this one. It comes from something called mass.wikispaces.com, scientific method. I just want to reaffirm it's not the model, but I found it kind of an interestingly helpful model. You're free to go look for one for yourself, but this one is a kind of a good reference point. Be mindful as you're conducting your observations, experiments, your science, your business research, etc. Disproof is success too. In business, when is it the best time to discover you're wrong about something? That marketing campaign isn't going to work. That product feature isn't interesting to customers. A new product development effort isn't going to pay off. When is the best time to discover that? Maybe the business idea isn't going to pay off. Well, the best time, you might agree, is to discover as early as possible. But when do most people discover, or perhaps politically acknowledge, this isn't going to work out? Far, far, far too frequently in business. That occurs long after the resources have been squandered, the time wasted, the opportunity costs lost, etc. So be mindful in doing this, it's spending a little bit of time up front. Using empiricism and rationalism can really pay off big time in the future, particularly if you avoid doing something that won't help your firm. In a couple of weeks, you're going to be introduced to the skepticism assignment, and when you are, you'll want to be especially mindful about how disproof was ignored as you go through that particular exercise. Here's some beneficial things you might spend some time learning or gaining knowledge about regarding the application of the scientific methods to business. First of all, what does this term rationalism mean? What is logic? What's deductive logic? What's inductive? What's abductive logic? Are they the same thing? Are they different things? Do they have shared characteristics? Do they have different characteristics? When would you use one approach over another? Do you never use inductive reasoning? Inductive logic? Or do you always use inductive logic? How about deductive? Do you use them together? Do you use them apart? It would be to your benefit to understand that. Then what is reasoning? What does empiricism mean? What's the distinction between an observation and an experiment? In a business context, how do we detect problems or opportunities? What are the appropriate uses of induction versus deduction to detect or identify a problem or an opportunity? How do we define the problem or opportunity? Later on, we're going to talk about a concept called problem analysis. And one of the most important stages in problem analysis is to perform what's called problem clarification. How do you know you're even solving the problem, the most important problem? One of the ways you do that is you form an operating hypothesis. You do this all the time. You may not recognize that you're doing it, but you are. For example, If you've ever been in a situation where you say, I think this is the way we should approach that group project, that's a hypothesis. Maybe it is, maybe it isn't. I think this marketing campaign is going to pay off. Maybe it is, maybe it isn't. I think this headline is going to be a great headline. Maybe it is, maybe it isn't. Those are all operating hypotheses. I think we should go into this market. I think we shouldn't go into that market. I think we should have this product. I think we shouldn't have this product. I think we should add this feature. I think we shouldn't have that feature. Those are all operating hypotheses, suitable for confirming or refuting with a combination of rationalism and empiricism. Then how do we do that? How do we do information collection? We need data, observations, experiments perhaps, and opinions? Well, wait a minute, Dr. Hubbard. Didn't you say we don't do opinions? Well, what about expert opinions? And sometimes opinions are all you have to deal with. You know, if you're talking with a sales team, they're going to have opinions about what customers want. Does that mean they're right or wrong or somewhere in between? But it would be foolish to ignore them as a source of input into your analysis. What does it mean to do analysis, to analyze? Our goal is to support or refute, confirm, or deny some conclusion. We want to be mindful of implications of choices and changes and the process of choosing one alternative over another. And then we form conclusions. They can be substantiated, they can be unsubstantiated. What's the difference? How do we know? These are all things you're encouraged to understand, especially as you work through the list. As we draw to a close in this video lecture, you are encouraged to gain a deeper understanding of the concepts of epistemic rationality and how these concepts can help you in your career. That concludes this video lecture on applying scientific methods to business problems and opportunities with a special emphasis on strategy. I'm Rick Hubbard, looking forward to seeing you in class. Please be encouraged to raise any questions or comments on this.